In this lesson, we're going to look at how we can use even and odd functions to make integrating a little bit easier. Let's look at what the integrals of even and odd functions can do for us. Let a function f be continuous on a closed interval from negative a to positive a, where a is greater than 0. If f is even, it would look like this, where it's reflecting over the y-axis. Remember that an even function means that when you plug in the negative of x, you get the same y value back out. What that means is when we go over to some x value, we have a corresponding y value. And if I go to the same x value but negative, it's the exact same y value. So I plug in a negative x, I get the exact same value out. So if I were to have a region of area that is going from negative a to positive a, meaning it's creating the exact same area on the left side of the y-axis as it is on the right side of the y-axis, then I can simply, instead of doing the integral from negative a to a, double the integral from 0 to a. That way, I don't have to deal with any negative values when I plug them in. On the other hand, when x is an odd function, where when we plug in a negative x, we get the negative of the y value out. Look at this, when I plug in positive 1, it takes me up to positive 1, and when I plug in negative 1, it takes me down to negative 1, or whatever that value may be. It just matches it, but it's negative. So when I create area going from negative a to positive a, it's the exact same area just below the x-axis. So those areas cancel each other out, and therefore, if I'm taking the integral of an odd function from points equidistant from the origin, that's simply 0, and I have no work to do. Examples: find each definite integral. The integral from negative 4 to 4 of x to the 7th minus 4x cubed plus x dx. Now, I notice that this is a polynomial that has odd exponents. So most likely this is an odd function. Let's look at how we can check that. I'm going to take the function, I'm calling this function f of x, and plug in a negative x. So that means negative x instead of x to the 7th minus 4 times negative x instead of x to the 3rd plus negative x. Now when I raise a negative exponent to an odd power, it leaves it a negative number. And here I have the same thing, so that makes plus 4x cubed and then minus x. Notice this is completely the reverse of this, so this is the same as saying negative x to the 7th minus 4x cubed plus x, which is exactly the negative of f of x. Therefore, this is an odd function, and I can simply say this equals 0. Now, do I have to show this? I don't. I just want to check to make sure that this is an odd function if I don't know that it's an odd function. Sometimes it's helpful to do that. If I simply know it's an odd function, then I just do the definite integral, see these are equidistant, which is important, and therefore the integral is just 0. And that's it. Let's look at the integral from negative pi over 2 to pi over 2 of 3 cosine x dx. Now, if you remember what the cosine function looks like, that is an even function. It reflects over the y-axis. So I know just by looking at a graph that the cosine function is even. Therefore, I know how to use my shortcuts. But just to practice proving it, in case we're not sure, if I plug negative x into where the x is, that's going to make the exact same value. How do I know that? Well, I know about how the cosine function works, either graphically or on the unit circle. If we take a positive angle or a negative angle, it's still in the region where the x is positive. Positive here and positive here. Therefore, either of these make the same value. So notice that that gives me exactly f of x, so therefore this is even. And now instead of this integral, I'm going to rewrite it as 2 times the integral from 0 to pi over 2 of 3 cosine x dx. And now I can do the antiderivative. I'm just going to multiply the 2 times the 3. The antiderivative of cosine x is sine x. 0 to pi over 2. We'll first plug in the pi over 2 minus, and then plug in the 0. And now we can compute sine of pi over 2 is 1 and sine of 0 is 0. So our final cleaned up answer is 6. Thanks for watching.